Well, I don't want to make anybody stay late, so I'm going to start. And thank you for not slipping out to catch an earlier train or whatever your options were instead of coming and listening to me. This is actually the first time I've given this talk, so I hope it's a talk. I hope you like it. I talked yesterday about code as communication, right? So we write for the compiler in that if we don't write in a way the compiler is happy with, we don't get what we want. So we have to write for the compiler. But they don't care what you call your function. Right? We care, right? So we're trying to read our code, we're trying to understand our code. And of course, we hope that if we have to come back to this code tomorrow or in 6 months or in 10 years, that we will also still be able to understand it, or perhaps that we can pass it off to other people and they won't be coming back to us to get us to explain it. So I really strongly feel that, yes, you're writing code to solve a problem. You can't forget that, but it's also a way of communicating and communicating with our future selves. And with some future people we don't know yet. Roy Rogers says a stranger is just a friend you haven't met. So your future maintainer is just a friend you haven't met. And so we leave behind kind of trail markers. And trail markers vary in their usefulness. In this picture, I took this picture because I thought it was ridiculous that you could have a canoe on your head, and if you took the wrong turn, you'd be on the 50-mile trail. Portagers go straight, hikers turn left. But it's not the big picture that I want you to see. It's the two little. There's a yellow diamond and a blue diamond nestled in the trees, right? And that the hiking trail is got the blue diamonds every once in a while, and the portage trail has the yellow diamonds with the universal portage symbol, Mr. Canoe Head. And that's what you're leaving in your code. And some of them are big and obvious, and they say, this is an intersection, pay attention, you do not want to carry your canoe 50 kilometers. And some of them are much more subtle, like that little blue diamond. So compiling is necessary, but it's not sufficient. It's not really what we're here for. It's not enough that it runs and works and doesn't explode. You want people to understand the code. And that means that reading code is a skill. You ask yourself questions while you're reading code. You say, what does this do? Why is it doing that? Does it actually do what it claims to do? Like it says it updates the orders, but I'm not seeing any updating happening, so I don't know why it's called update orders. And all those conversations, that monologue back and forth in your head while you're reading the code. And my favorite, of course, is like, what kind of terrible person is responsible for this atrocity? And it's usually me. And I'm sure whoever it was never thought about blah, blah, and blah. So when you write code that's well written, right? Yeah, it works. I'll stand for working. And it works even if you go to a different compiler, and it works even on another platform. But also, it has pre-imagined those questions being asked, and the code itself answers them. Not like this. We used to have to do this all the time, and they were terrible. They were never useful at all. For one thing, it would say things like calculate efficiency. Purpose calculates the efficiency. Oh, I've learned something. That was helpful. But it answers them because it tells a story, because it expresses your intent, because it leads the reader through what you're doing. And so in that context, I started thinking about the amount of information you could convey with the least number of tokens. Right? So if I write a giant loop to sort something, I might need 100 lines of code. Or if I just called std sort, if I've got a namespace in place, I might just need 4 letters to get across the idea of sorting. And maybe your code can be considered to be pretty expressive if you think about that ratio of the amount of information you're getting across versus the number of characters you're using up. So who was at Bjarne's talk on opening night, right? So he quoted this too. This is a very popular thing to quote. There's, wow, like think about what you're saying in that single character of space. You only used up a byte, and yet you're saying, please clean up everything that was on the stack and la la, there's all kinds of stuff going on here. But I can beat it. with this. There's no build, that's the slide. Sometimes not saying anything doesn't mean anything. Here's a class. If you've ever written any introductory C++ stuff, you've probably written a class like this. It's called holder. It holds a number. That's the private member variable. It's got some constructors and some functions that do some stuff. Take a look at this version of holder. I'm just going to go back to this one and then this one. Oh, so in the first one, when we didn't say anything on the one argument constructor, we didn't say explicit, we were kind of saying something, right? We were saying you can just ask the compiler to make you a holder out of a random integer if there's some context where the compiler feels like doing that. Get number and toString are now marked as const, meaning that they do not change the number. And I would hope so, right, from their names, but compilers, remember, don't care what things are called. Back here, we didn't bother marking them as const. And we also didn't bother marking toString as virtual. So if we were to extend holder by inheriting from it, would we want polymorphic behavior on the toString? I don't know. So the absence of these red keywords in the other version of holder was in fact carrying information. And as a code reviewer, as a pair programmer, as a side-by-side teammate, we're often called on to notice that absence of information. So earlier today, we were told AAE, almost always explicit, noticing that the first constructor there is not marked explicit and saying, hey, should you think about marking that constructor explicit? And maybe the person would say, no, I totally want to be able to just randomly pass integers to functions that take holders and have them get wrapped up without any work on behalf of the caller. But they're not telling you that by leaving it out. Now, a lot of things in C++ come in pairs, right? Plus is the opposite of minus, and times is the opposite of star, or maybe address of is the opposite of star, so on. But there's all kinds of stuff that doesn't have opposites. They just are. And I want to talk about this set. So we have virtual and its cousin override. We have explicit. Const, the opposite of const is not always mutable, right? I mean, they are opposites, but not completely. There are contexts in which you can say const and then you can't say mutable, and vice versa. Public, private, sticking ref qualifiers and CV qualifiers out on the ends of functions, but also on your parameters. And two things I want to talk about specifically because they're new in C++ 17, fall through. And who's seen fall through before and recognizes this? Just a really small number of people. So if you don't break at the end of cases, you fall through to the next case. And some compilers will warn you. So this attribute, which is a C++ 17 attribute, doesn't change the way your code behaves in any way, shape, or form. Okay? The only thing it does is, in a cross-compiler way, tells the compiler not to warn you because you're doing it on purpose. Compared to // fall through, which tells humans to leave you alone about it, right? So this is to tell the compiler to leave you alone about it. You can have opinions about whether or not falling through is good or bad, but that's what that attribute is for. So without it, you're relying on a person noticing there's no break in case 3 and being okay with falling through to also do the case 4 stuff. And we also have two more attributes. Again, they don't change how your program works, they just change what the compiler has to say about it. We have maybe unused. This is perhaps pointless, but then perhaps not. Here's why you need it. Building this code in debug, the assert stays, and the j is a used local variable. You build the same code in release, the assert falls away, now the j is unused. Now you could argue, well, why don't you just assert function with side effects? But you know why, right? Because you want the side effects in release or in debug. So, I mean, you can do dumb things like after the assert, I'll just arbitrarily set j to another number, or I'll increment j or something just to shut the compiler up. That's not smart. So maybe unused says, trust me, I have my reasons for why I'm putting this in this variable. Do not warn me if I then do not go on to use the variable. The opposite of that is no discard. The question was asked, it's starting to blur together. I can't remember if it was yesterday or today. When did you last check the return value from printf? Right? We have functions where checking the return value is actually super important. And so if you call getNumber, I expect you to put the resulting number, which is a very important one, into a variable and not throw it away. And if you just call getNumber, I'll give you a warning, and I'll tell you, you shouldn't have done that. You shouldn't discard my warning. So this brings up the idea of a couple different kinds of nothing, because that's a piece of nothing right there. When I just call getNumber, and I don't put its return value into anything, and I don't pass it to an if, I don't in any way use it, that's a nothingness that, again, as a code reviewer or a side-by-side pair programmer or whatever, to react to and say, hey, why is there nothing there before that call to getNumber? Why aren't you saving the number in a local variable that you're going to do something with? Why did somebody go to the trouble of writing a function that returns integers or strings or whatever it returns if you don't care what it gives back? Now, whenever I ask a question, why, that's actually literally what I ask. So why don't you use the return value is not the same as you should use the return value. Okay? Someone may have an answer, but why isn't the answer in the code? So, and I don't mean that you put a comma after the end that says, I don't care what this function returns. There has to be a story that the code leads out to you about why, how many bytes were successfully written or whatever is not important to you. So I'm imagining myself writing in a room all alone. And I'm writing code, and because so many of our defaults are wrong, I'm specifying some things and leaving some things at default, but not many because so many of our defaults are wrong. But I want to tell the people after me, I did this on purpose. This is not a nothing of forgetting. This is a nothing of a choice. And that's really the key point here. And I don't necessarily have an answer to it. How do you communicate that in this particular case, the reason you didn't type any tokens whatsoever is because you made a deliberate, informed, expressive choice? So the first thing you can do is repeat yourself over and above the default. So when I write a class, and I know there are people here who don't do this and will just disagree because I'm right, I say class whatever, private stuff, public stuff. I know I don't have to say private because I know that's the default. I'm trained on that, but I do it anyway. And if I'm writing struct point, I'll go public and then the things. Yes, I know they're public if I don't say it, but I'm saying it anyway. It's harmless, it doesn't slow the compiler down, and it makes it clear that I actually did think about it. If you write a void function, you don't need a return statement at the end. And another case of the super expressive close brace, when we hit the close brace, we're done. It's harmless enough to count on that unless you also have a return in the middle. Right? So you have some kind of an if or maybe a loop or something that you, under certain circumstances, you'll blow out in the middle, and you don't have a return at the bottom. I don't know if you ever intend to come out the bottom. Like maybe you think it's an infinite loop and the only way they're getting out is from the middle. If you put a return statement last, then I know that you also expect to fall out of the loop or the switch or whatever it is and also return out the bottom. It's not needed for the compiler. Compiler would be fine if you call your functions A1, A2, A3, and so on until you used up as many numbers and then moved on to the B's. But for humans, put that return there, even though, strictly speaking, it's not needed. Every time you override a virtual function, put override on it. About once a year, you'll put override on a virtual function, and the compiler will say, you can't override that, it's not a virtual function. And you'll go, what? What? And then you'll go back and put virtual in the base class, which you had forgotten to do. But even when it's not catching that mistake, it's just communicating to the people who are reading the code. You could leave it off. Everything compiles fine if you leave it off. But I'm just asking you, please don't leave it off. And we have no except false. You know what the difference between no except false and absolutely nothing is to the compiler? Absolutely nothing. But to humans, it says, I thought about this. And baby, I throw. Deal with it. Okay? It gives you a chance to put kind of a stake in the ground and say, this is what this function does. You could leave a comment, but Bjarne says the compiler doesn't read comments, and neither do I. I'm going to adopt that as my philosophy too. However, we do not have implicit. We do not have const at false. We do not have non-virtual, and in the nod to the Visual Basic heritage, we do not have by val. Right? So when you take a foo versus taking a foo ref, right? We don't have this like, danger, danger, I'm doing this. We don't have these keywords. Don't do this. I've seen this. Don't do it. Not because it's arrogant or anything, but because it's vague. Okay? I mean, you may feel while you're typing it that the oddity of your code is obvious, and so you can just say, like, stop, I know you think you're smarter than me and you want to change it, don't change it. But 5 years from now, I may not be clear on what it is that I'm not supposed to change. This is only marginally better. Okay? Here I'm being really specific about what I'm doing. That's good. But now I have no reasons. Like, I did this because reasons is not actually an explanation. So we're back to this issue that if I leave a keyword out, did I not think about it at all? Or did I think about it and make a careful and considered decision like the expert that I supposedly am? And often the best way for me to get an answer for that is to look at the rest of your code. So if you think back to the 2 versions of holder, once I marked get number and toString as const, you knew that inc changed number because it's not marked const, and I'm clearly a const marking person. So it must be the only reason I didn't mark that function as const is that I can't mark it as const because it changes a member variable. When nothing was labeled, you had to guess based on their names or go and read the code, both of which suck as strategies for guessing. So having a consistent, I use override, I mark things const, I take things by reference, I this, I that. Then when I don't, this is a thoughtful developer who would have done it if it was appropriate, therefore doesn't consider it appropriate. If you have to put in a comment, only do it where you think you're maybe tricking people. So this comment says, I know this looks like it might be an override of foo, but it's actually a different signature. So I didn't put the word override on it. Normally I would. I didn't put an override on it because it's not an override. And then I'm being really specific about why it's not an override, that the signature is different in some way. If you, for some reason, don't have a return at the bottom of your void function, maybe a comment that says, we never return out the bottom. We only return from inside that if, or what have you. So think about other choices you can make in your code. This is maybe coming a little bit off my brief of, strictly speaking, leaving out a token. If I have a raw pointer, a T-star, am I just pro pointers and enjoy typing new and delete? You know, who owns this PE? Is send emails responsible for cleaning up afterwards? Or can I be confident that, hey, this person would never give me a raw pointer unless it was strictly for observer purposes? It's harder here if send emails is going to return a message pointer. Like maybe they created that and I'm supposed to clean it up, right? And you don't know. Yeah, you could go read it. You could also go read the wiki, but I bet you're not going to, right? But if I look elsewhere in the code and I see that this developer has heard of unique pointer, has heard of shared pointer, then the fact that they're using a raw pointer here, assuming it's not some transitional thing that's halfway through being converted into being more modern, this is probably just an observer pointer. I just gave you the pointer to the message in case you want to look at it, right? Okay, that's all right. I can't find any new, I can't find any delete, I can't find constructors and copy, destructors and copy constructors and move assignment operators and whatnot. Okay, this person's a stack semantics person, right? They're not expecting me to manage these things. Excellent, I don't have to manage them. So the absence, right, the following the rule of zero, that's a very powerful nothing. It says, this is all stack semantics here. We got people for that. Whether it's vector or whether it's string or whether it's the smart pointers, I got people for that. I don't manage memory. When you see a lot of that, then you can relax when you see a raw pointer. When you see all the hard work of people newing and deleting all over the place, and you see that I'm going to give you a message pointer, a cold, icy hand should be gripping your guts. You know, you realize, oh my Lord, I'm going to be responsible for that. I don't think I want to remember how to be responsible for that. Speaking of punctuation, if I take something by ref, if I take something by address as a parameter, you know, does that mean I'm changing it? Especially if I didn't put the const in there, again, back to the nothing. And there are people who have these as their style guidelines. You know, they'll say, if I give you a reference, I'm just trying to save the copy, it's yours to look at, blah, blah, blah. But if I give you a pointer, you own it and you have to delete it. You can read style guides today that say that. I hate it, but you can totally read them. The compiler doesn't care, right? Pass by reference versus pass by address, the only difference to the compiler is all the punctuation you have to type. But the humans may see a difference. And if you want to take that as a point you can communicate on, then you need to take on that consistency throughout the code base. You need to say, here's what it means when I pass by non-const ref. It means you will change it. Here's what it means when I pass by address, and so on. I was going to say I'm pro-ranged for, but that's not really true. I'm just anti-original for. I'm not super pro-ranged for, because I'd really rather you just called a function. But if I see a traditional for loop, right, for int I equals 0, semicolon, is that just another day at the office? Or is that like, wait, why not arranged for? What's going on? Maybe this loop does not touch every element. Because if it touched every element, you used arrange for, right? So there's something weird happening here. What's the weird thing that's happening here? Now, sometimes the weird thing is I need the index, right? I've had this from all kinds of people that are like, I need to know that I'm on the 5th element. So I did a traditional for loop. Which is an unfortunate response, but as I say, I always ask why, because then we'll solve that problem. Why aren't you calling find? Why aren't you calling count? Why aren't you calling all of? Usually the answer to why aren't you calling all of is, what is all of? And then we have a little conversation, and then they're like, wow, it turns out I'm not the only person ever who needed to know if all the orders have been shipped by going through and checking to see that all of them have their shipped bit flipped. But again, back to what you're doing in the rest of the code base. If all the rest of your code shows me that you know what count is, you know what sort is, you even know what rotate is and when to use it, but here you wrote a loop, now I'm paying attention, right? There's something going on here. I don't know what it is. I'm going to have to read the loop to find out. Maybe it's going to be exciting, but it means something now that you wrote a loop. Whereas your office mate, who can't even type algorithm and has never included the header ever, has got loops everywhere, and we're just like, ho hum, another loop. But here it means something. Where do you initialize things? Simon Brand has this blog post called Initialization is Bonkers. It's my new favorite adjective. He's completely right, but this isn't about that. This is about, I'm writing a constructor, and when I started teaching C++, we said the best place to set the member variables is after the colon, right? So what if something doesn't? You're looking at a constructor, and there's a member variable that is not initialized right after that colon. What's going on? Well, first of all, it's not the best place anymore. Actually, I think the best place is non-static member initializers if you want to initialize to a default value. Obviously, if you want to use the parameter from the constructor, no. But it's possible that the bank account's open date is today, and that's just what it is. We don't have to mention that in the constructor, or that the bank account's opening balance is 0, or who all knows what else, right? Sometimes people set things in the body. Again, why? Probably whatever they say is wrong, but I'll listen. Sometimes it's because of initializer order. For those who don't know, I don't have a sample here. You think the initializers happen in the order you write them after the colon, but they don't. They happen in the order the variables are declared. And someone who's been bitten by that, if they have something that has to be last, they'll initialize it in the body so they're 100% sure that whatever other things it's depending on have gotten their values. Not maybe the right fix, but it's a fix. But my favorite, right? We have 5 constructors, and we added, I don't know, status or priority or importance or something. And in 4 of the 5 constructors, we remembered about this variable and gave it a value, but in the 5th, we didn't, right? And so again, when I'm just looking at the constructor and I'm saying, hey, this doesn't set priority, I have to now work out why. I gotta go back up in the header and find, oh, it's a non-static member initializer, that's fine. Or maybe I gotta go into the implementation file and see that it's in the body. Like, I got a lot of like sleuthing to do about why you didn't do something. The solution to which, of course, is try to be consistent. Don't do half your variables with non-static member initializers and the other half after the colon. And every once in a while, one in the body just to keep me on my toes. The more consistent you are, the less time I spend being puzzled and trying to understand, did you forget about priority? Is that what happened here? And unfortunately, a lot of the time that is the answers. I can't rule that out. That's a really likely part of the problem. And what about these down here? String S equals quote, quote, vector of employee department, round brackets, 0. And while initialization is bonkers, I will tell you that gets you a 0 length vector. As it would if you didn't say round brackets 0, right? You just said vector of employees department, you'd get a 0 length vector. Just say string S, you'd get quote, quote. So compiler doesn't care, right? Runtime doesn't care. These have 0 impact on how your code behaves, but they have a huge impact on how I behave. Like, what are you trying to tell me? Do you not know the defaults? That's possible, right? Are you just coming from another language where there aren't defaults? Also possible. Did you used to have something in there, right? Did you used to like automatically, I'm just going to reserve for 20 because performance, and then discover you didn't need to do that, so then you just deleted the 2? So it's just reserving 0. So I want to shake the screen. What are you trying to tell me? What do I need to know? What's going on here? So this is the opposite of the rest. Most of the rest of the time I'm like, try not to say nothing. But here, nothing would be way better because the presence of this unnecessary code has gotten me perturbed. And that's really kind of where I'm at with this. What are you trying to tell people? What are you trying to leave trail marker-wise to say, I would like my string, unlike all other newborn strings, to have nothing in it? Okay. You guys recognize this? It's a little snippet. If you go to isocpp.org, you see sort of what's in flight and how we're doing standards-wise, and there's all this stuff, and there's a map out for the next X years. Do we want more? Right? Should we continue to add things to C++ to make it simpler? I'm generally a fan of that. But what would you do with implicit? Marking your constructor or your conversion operators or whatnot as implicit. To say, I've thought about it and I'm good with this. That one you may actually get, not in the form of implicit, but explicit at false. In the spirit of no except false, which I believe is really for template metaprogramming and blah, blah, so that you can wrap a value and then have the wrapper preserve the explicit requirements of the wrapped. But then I don't care. We could do it in a regular class if we get it. We could say explicit at false on our constructors. And just like no except at false, it means I have thought about this and here's my decision. So we may get that one. I don't think we're going to get const at false. I don't think we're going to get non-virtual or virtual at false. I don't think we're going to get by val for when you're taking something by value and you actually meant to take it by value and you didn't just forget to type some punctuation. But how do you feel about them? Like, do you want the language to gain more keywords? Is this how we fix our problem with our defaults being backwards? How can you express right in the code in a way that stays, I didn't just skip it? So we have fall through, we have maybe unused. They change nothing other than the brain, well, maybe your compiler warning, but mostly the brain of the person who's reading your code. Anybody using them at all? 3 hands in the whole room. So that's the natural question that I would ask in a code review, like, why not? Now, maybe it's because, why, I always use my local variables. Or I never fall through in switches, so I don't need to be able to say I'm deliberately falling through in this switch. And those are good answers. But there's also a fair amount of like, we're not on C++ 17 yet, which is probably still a reasonable answer, and I don't know, I never thought about it. And I think most of the nothing in our code today is a giant pile of I don't know, I never thought about it. And that's what I really want you to do. I want you to think about how to change all of your nothings from I never thought about it to you can trust me on this. This is a choice. It's a very narrow choice that took no time to type, but it took a lot of time to think, and I want you to read it and to see that nothing as the choice that it is. Because, you know, code is communication. You're telling that future reader, which could be you, and when you get to be as old as me, the time frame in which you forget what on earth you were thinking when you wrote it goes down a lot. When I was 20, I wrote code. 5-10 years later, I could read that same code and I knew why I did it. When I get home sometimes from conferences, I go back to what I was doing when I had to leave for the plane, and I'm like, what idiot did this? It's a fairly small group of potential idiots that it could be, especially on my own laptop, right? So what am I telling that future me? Why did I do this? What can I leave in the code itself, not in a comment, that will tell people why I did what I did? Don't leave people mysteries. I know our work days could be a little more interesting than they currently are. I get that. But this is not how we spice up our work life, by sitting there going, what? Why? Who? Oh, good. Here's a comment that says it was in 2002 by Joe Programmer. I feel better now. And let's defend our own reputations, right? You don't want the next person saying, what complete buffoon is responsible for this? You shouldn't talk badly about yourself. It's not good for your self-esteem, right? Negative self-talk is bad. So leave behind things that won't cause that negative self-talk by you about you later. And really, it's what's not on the screen and what's not in the code. I don't think much of us think about that very often. We want to type, we want to hit run, we want to get the tests going or get the debugger loaded up so we can see it all happening. And even when we read it, we read what's there. And so all I'm really here for today is to say, think about what you didn't do. Think about a different way you could have done the same thing, because this is C++, and we have 7 ways to do everything. And think about the message that you're sending with the choices that you made. You could have used arranged for, a regular for, a while. Do you remember that when style guides would have like 15 pages on how to choose for versus while? I would be in arguments like late at night over adult beverages about, no, you should only use a while if you don't know how many times the loop is going to go, like if you're reading a file and things like that, which was kind of nonsense. But you are communicating when you make a choice like that. So think about what you're communicating and do it deliberately, because although it seems like a just random flip a coin, I like to alternate between fors and whiles, there's actually a potential for you to carry a little bit of extra encoded meaning in what you're doing. I would prefer it if you could communicate without any nothing. Toss the override on the end, right? Say public, say private, put in a return statement. Who's it going to hurt? That's my personal preference. You cannot always do it. So if there is no way to say implicit, non-virtual, by val, put context around it, like this code is full of smart pointers, so this is almost certainly just an observer pointer that gives people what they need to understand what that nothingness is saying in this context. And really try to use your nothings in a generous way and give the people who are reading your code what they need so that your nothing is actually highly communicative. It speaks volumes. It tells them what you mean when you say nothing at all. Thank you. I have time for a small number of questions for those who don't have trains and planes to catch. Tony.
Would you put return on all your void functions or only the ones that early return?
That's a good question. So should you always put a return at the bottom or only if there's another return somewhere else to fool people? Probably the beginner level would be always. And then if you totally knew what you were doing, you might be able to have like a return free function. But even then, there's still that moment of puzzledness from someone who's like, I don't understand. How do we get out of here? Oh, right. It doesn't actually return anything, so it must be at this close brace. And although it's a very short puzzle, like it probably wouldn't win a lot of prizes as puzzles go, it's easy enough to skip it. Yeah. But not too much, because are you saying string s equals quote, quote? Like,
well, see, the return one, if I do see it, if you start using it as a habit, then I think it loses. Then if you have something that is looping forever and you only exit out of here, the person's going to put a return at the bottom anyhow. It never gets it.
Okay, so the helpful tidier upper who comes and adds a return where it will never be reached. Right, and the compiler can't tell because it's not maybe while true or something, so you're not going to get unreachable code detected. Yeah. Well, all rules contradict each other. Yeah. Here.
For example, with the comment at the end of the void function, rather than return if it's not supposed to reach there, should that be assert?
No, because in so I personally don't write asserts that can't run. Assert we should never get here, I don't do. If we should never get here, maybe I'm going to throw or something if we do get there rather than just, I know the assert has the advantage of compiling out. The comment saying, the only way out of here is the return in the middle of the while true would at least prevent the Mr. Helpy from coming along and adding a return at the bottom that can never be reached. You can certainly come up with a strategy that works for you. To me, the important thing is the consistency. If I know that you would have put a return statement if control would fall out the bottom, then I don't see a return statement. I'm like, I bet control never falls out the bottom, and I go in and look a little closer at the while. But if you're random about it, sometimes there's returns at the bottom, sometimes there isn't, then I haven't learned anything and I have to go read the loop. And this is really about taking away those moments where I'm trying to puzzle it out and understand what it does. I'm biased to that because I spend a lot of time doing that. People are like, hi, here is a million lines of code that we don't understand. Could you understand it? And would Thursday be good for when you will tell us what it does? And so I've got this like allergy to, that took me 14 seconds that I shouldn't have had to spend, But they add up. They really add up. All right. Thank you all very much again. And I hope I see you next year.